In this video, I'll be showing you how to read a battery, what some of the information means, how to assemble the battery pack, know what the wires represent, and what these are as well, and how to read a battery pack. Let's say you have a singular battery. And it has been labeled as a 18650. Well, what does this mean? This is a single cell. You can think of it as one power unit. And this is just the dimensions of the battery. 18 millimeters diameter of this cylindrical shape. 65 millimeters lengthwise of the battery. And the 0, well, that just represents that this battery is a cylindrical shape. For example, let's say we're using a regular Li-ion battery. Usually it might have 3.7 volts. Fully charged, it would probably have 4.2 volts. Well, you might have seen things as in two batteries connected like this. Well, what does this show? It shows two cells and one parallel. Well, we don't say 2. We don't say 2C. We say 2S, because S is cells in series. Well, and yes, we still say parallel because it is literally one parallel. So P is parallel. Okay. Now what does this show? This shows that there are literally two cells in series, meaning this is a 2S, 1P, as there's only one parallel. Let's say you had something like this. You had basically them stacked, sort of. Well, what do you think this is? This is not a 1S 2P. That is not what it is. This is still considered a 2S 1P. We don't use things like 1S 2P or 1S 3P, as it would have one cell in series. It'd be 3.7 volts and 3 cells, and like 2 cells in parallel. The voltage does not increase, but the current capacity, which is how much power it can deliver, would increase because you have 3 cells in parallel. But this wouldn't be as useful as just saying it's 3 cells or like 2 cells in parallel to have more current. You don't need to specify that it's 1S, since the voltage continues to stay the same. So this is still a 2S 1P. Let's say you have a more complex configuration for a battery pack. You have 3 cells here and another 3 cells on the bottom. Well, what does this show? It shows that there are 3 cells in series and that there are 2 parallels of them. So this is a 3S2P configuration. Now, let's say you wanted to know the voltage and maybe the current of this, also amperes. let's say each one of these cells has 3.7. Well, in one of these parallels, there are 3 cells. So then you do 3.7 volts times 3 equals, that's right, 11.1 volts. So this battery configuration would have 11.1 volts total. But then now, how do you find the amps? So let's say each battery can have a current of like 10 amps or something like that. Now you will multiply the amps from one singular cell times the number of parallels. So this would result in 10 amps times 2, because there are 2 parallels, equals 20 amps. So basically, to find the volts, you multiply the singular cell voltage times how many cells are in a series. And then to find the amps, you take the singular cell times the number of parallels, and you get your total amps. Using this, now, what is this battery configuration? Well, this is a 2S, that's right, 3P, because you have them in parallel. Now, what would this do? You have 3.7, again, in one cell, and then you have a series, right? So you get 3.7 times 2 equals 7.4 volts. Now, you might be wondering, well, don't they have the same number of batteries? Yes, they do. But in battery configuration, when you have less cells in series, you get less volts. However, there's an upside to that. You do increase the current. So let's say this is 10 amps. So then you get 10 A times 3 equals 30 amps. Compared to the 3S2P configuration, yes, you might have more volts in this, but you have less amps of the current. And in the 2S3P, you have less volts, but you have more current. So by having more parallels, you can get more current, and by having more cells in series, you'll have more volts. Well, let's say you want to build a battery pack and you don't know how to do the configuration. Let's say you want to do a simple 3S1P. You would have a battery up, a battery down, and another battery up. Let's say you want to expand it even further. For each parallel, just follow this pattern. So these would be all down, up, and up. Well, how do you connect these? Well, remember, this is positive, negative, and positive, negative. So first off, please never connect all these 3 at once. Always have a system where you connect these and these, so you have a smooth flow of electricity. Now that you have this knowledge, you want to know how you should set up the wires. Usually in a battery pack, there are only 2 different colored wires: red wires and black wires. Well, let's say you need a head, like connect to the some sort of thing in the airplane. Let's say we're using the XT60. It is a very common port. So you connect the open-ended positive to that, and the negative-ended open-ended thing to the XT60 as well. usually the positive is the red wire and the negative is the black wire. Okay, well, you have another port here. Yes, this is usually for charging. How you do this? You would again take your negative, open negative here, connect it, and yes, take your open positive and connect it. But now what? It needs more than just 2 wires. It actually needs a total of 4. So you have to connect the connectors, and in this case, you'll be using black wires most commonly. Remember, this is still red, and all these are black. Okay, so now, let's say you don't know the number of batteries in there. How would you know? Well, in this case, just subtract 1 wire from the number of wires that are here. So, let's say 4 minus 1 equals 3. So you have 3 batteries. And recalling, this would have 4 slots, and this one there are about 7 slots because, you know, this is the positive, these are all the other connectors, same thing, and this is like an XC60 as well, red positive, black negative. That's basically it. Okay, well, now that you have this understood, you need a wrap. So go online and find some battery wrap for your battery pack, like this blue one, because you do not want these batteries exposed to the outside. And then if you don't have that, you could use electrical tape. So you basically, for example, this, you're going to wrap it extremely tight. And what I did is I kind of shrink wrapped it so it get on there pretty smooth. But the electrical tape, I just taped it on there really nicely. And some additional information, if you want to secure these batteries well, yes, you can use a strap, but I recommend using some Velcro padding for a pretty good stick, especially when there's going to be a lot of movement. So things like an 18650, this is the dimensions: 18 millimeters diameter, 65 millimeters length, cylindrical shape. P and S, cells in series, and P is just parallel. Further, you can now read a battery pack, or like some sort of battery configuration, very simple, like 3 batteries, like this, 3 cells in series, 1P. And you can go reference back to this on how to set up your battery pack configuration. Remember, always follow this pattern where it shows positive, negative, negative, positive, positive, negative, and so on, so on. Alright, connect these, your XT60 plug. Remember, connect the open-ended negative and positive to this, and your charging plug, and for this example, it was a 4-slot, so then negative, positive, connectors, and that's it.